Hello guys, today we're going to be solving some of the questions we are given as a take home in our previous lesson on calculation on molecular mass and atomic mass. In our previous lesson we solved a couple of questions and we're given some questions to get ourselves tested to see how much we understood from the day's lesson. So today we're going to be looking at the solution for all these questions. So this question was the first question we are given as a take home. Number one, find the molecular mass of calcium hydrogen triisocarbonate 4. Now, before one could get the molecular mass of this question, it's very important for one to be able to write out the chemical formula for this very element, for this very compound, and successfully. So, how do we write calcium hydrogen triisocarbonate 4? We've done this in one of our lessons. It's very, very simple. Triisocarbonate 4 itself is CO3 with a valency of 2. Then hydrogen coming in, CO3 itself, the CO3 here, which has a valency of which has oxidation number of -2, we all know that. Then hydrogen itself has oxidation number of +1. So by the time we combine them together, what do we have? +1 -2 will give us a -1. That's what we have. So by the time we add calcium to it, calcium hydrogen triisocarbonate 4, calcium hydrogen triisocarbonate 4. That calcium itself is 2. You have calcium itself is 2. Remember, don't forget that. Then hydrogen triisocarbonate 4, HCO3. By the time you combine it together, don't forget that this calcium carbonate itself, triisocarbonate 4 itself has a valency of 2. Oxidation number is -2. That is when we talk about oxidation number, I could call this, in a way, you could call this valency. Right? But don't forget that valency itself doesn't really have a business with either +2, +1, or whatever, just neutral, because it's all living compared with hydrogen. So HCO3 here has valency of just ordinary 1. So Ca, which is calcium, which is +2 oxidation number, valency 2, HCO3 is 1. We cross multiply, we end up with CaHCO3 in bracket like this. So this calcium hydrogen triisocarbonate 4. So now we carry on to get our molecular mass. So what's the atomic mass? Don't forget that atomic mass is being brought together will result to molecular mass. So what's the atomic mass of calcium? Calcium is 40. We gave all the things we given in our previous lesson. We stated out all the atomic mass for each of the elements involved in each compound. So calcium is 40. Hydrogen here is 1. That is carbon is 12. Oxygen is 16. So we're just going to combine it together. So we have one atom of calcium here, which is 1 times 40 right here, then plus. Now hydrogen here is one atom of hydrogen, but we have 2 atoms that is general for all of them. That's this one atom came from this calcium. So hydrogen here, 1 times 2 is 2. So that means hydrogen is 2. 2 atoms of hydrogen, 2 times 1, then plus. Carbon right here is 1 atom of carbon right here in the bracket, but we have a general 2 outside. That is 1 times 2, 2. So that is 2 times 12. Then oxygen is 3, as you can see, but with the general 2 outside, that would be 6 atoms of oxygen. That would be 6 times 16 altogether. So what do we do next? 1 times 40 is 40, plus 2 times 1, 2. 2 times 12 is 24. 16 times 6 give us 96. So we're going to sum them all up. So 40 plus 2 is 42. So 42 plus 24 is 66. 66 plus 96 will give us 162 gram per mole. So this is our molecular mass for this very compound, calcium hydrogen triisocarbonate. As simple as that. Question 2, we are asked to get the molecular mass of zinc nitrate hexahydrate. Zinc nitrate hexahydrate. Now, before we can get the molecular mass or the relative molecular mass of this very compound, the first thing we have to do is to look for a way to write out the chemical formula. It's very, very important. If the right chemical formula cannot be written down, there's no way you can get the relative molecular mass or the molecular mass. So the first thing we're going to do is we're going to write down zinc nitrate. Don't forget that this zinc nitrate is zinc triisonitrate 5. Zinc triisonitrate 5. Now let's analyze it. NO3. That's what we are talking about. And when you look at oxygen, oxygen has an oxidation number of -2, while nitrogen Nitrogen is plus 5. When you look at nitrogen is number 7, that's atomic number of 7. So it's the 7th element on the periodic table. So when you write out the electronic configuration, you end up with 2, 5. So oxidation number is plus 5 or minus 3. So we're going to use plus 5. The first has to be positive, the second has to be negative. So NO3, which is 1 atom, and oxygen, which is 3 atoms, that's going to be 1 times, plus 5, plus 3 times minus 2. By the time you combine it together, that will be 5 minus 6, which is minus 1. So NO3 is an anion. It's a complex anion. We all know that. So the valency for NO3 is just 1. Don't forget that valences, when we talk about valence, we're talking about combining power. So for valences, you're not talking about if it's positive or negative. Valency doesn't really carry any major charge. So NO3 is 1. That's valency. So let's get our chemical formula. Zinc itself. When we talk about zinc, zinc has a valency of 2. NO3 has a valency of 1 from what we're saying. We got our valency from the charge NO3 carries. So let's cross multiply. So zinc itself, zinc is 1, NO3 is 2. So here is our chemical formula. So this Zn, NO3, 2. So it's high time we solved for the molecular mass. So first of all, we're going to get the atomic mass for each of these atoms of element that we have. So for zinc, zinc has an atomic mass unit of 65. Nitrogen has 14. Oxygen has 16. And don't forget, we're talking about zinc nitrate hexahydrate. So we're talking about zinc nitrate hexahydrate. That's what we're talking about. There's an hexa there. Hexa there is 6 H2O, 6 molecules of water, 6 crystals of water. So hydrogen is 1. So everything is set for us to solve for the molecular mass. So what do we have? So zinc is 1 atom. That will be 1 times 65. Then plus. Don't forget, nitrogen here is 1 atom, but we have a general 2 atoms for NO3. So nitrogen altogether has 2 atoms. So that will be 2 times nitrogen atomic mass unit 14. That will be 2 times 14 right here. Plus oxygen here has 3 atoms naturally. We have 2 out here. That will be 6 altogether. Plus 6, open your bracket, oxygen naturally. Oxygen has atomic mass unit of 16. So what do we have next? We're done with this. So we're going to work on all those ones now. Now hydrogen here is 2 atoms, but we have a general 6 out there. That's 6 crystals. So hydrogen here is 12 atoms. That will be 12 times 1 right here. Then plus oxygen here is 1, but the 6 here makes it times 6 atoms of oxygen. That will be 6 times 16. So what do we do next now? We're going to open up the bracket. 1 times 65 is 65, plus 2 times 14 will give us 28. Then plus 6 times 16 will give us 96. Plus 12 times 1 will give us 12. Then 6 times 16 will give us 96. So the next thing you're going to do now is to add up all this. You're going to sum up all this. 65 plus 28 will give us 93. 93 plus 96 will give us 189. 189 will give us 189 plus 12. When we add it, 9 plus 2, 11, 1. That will give us 201. So 201 plus 96 will give us 297 gram per mole. As simple as that. So this is the molecular mass for zinc triazonitrate 5 hexahydrate. As simple as that. Okay, guys, this question was the final and last question we were given as a take home in our previous lesson on calculation of atomic mass and molecular mass. So we're asked to get the molecular mass of sodium dioxoaluminate 3. So sodium dioxoaluminate 3. Now, how do we write out the chemical formula for sodium dioxoaluminate 3? So it's very simple. Don't forget, right here we have dioxo. So we have 2 atoms of oxygen. The aluminate, which is aluminium. Now let's analyze that. Now aluminium naturally has, when you look at aluminium, a major metal, it has an atomic, it has oxidation number, of 3. We have just this plus 3 here for aluminium. Then oxygen right here, which is dioxo. That's 2 atoms of oxygen. We have oxygen naturally has minus 2 oxidation number. So when we analyze this, we end up with 2 times minus 2, which is minus 4, plus 1 atom of aluminium, 1 times plus 3 altogether, we have minus 4, plus 3, which is minus 1. So naturally, dioxoaluminate, naturally has, we have a radical of minus 1. So when we link it up with sodium naturally, we look at sodium, which is natrium. Sodium, we're talking about, I think, the 11th element on the periodic table. So the sodium naturally has plus 1, 281, plus 1 oxidation number. So when we link it up with the AlO2 that we have here, we end up with plus 1 minus 1, which is, so this doesn't have a radical, really, doesn't have a charge, which is 0. So there's a, right here, this is what we have, there's the chemical formula. So you have NaAlO2, which is sodium dioxyaluminate 3. So we're going to get the molecular mass right now. You know what it is. So sodium naturally, sodium is natrium 23, aluminium 27 atomic mass unit, then oxygen 16. So we're going to use all this to get our molecular mass. So sodium dioxyaluminate 3 is going to be, now if you look at the sodium is just one atom of sodium. We have right here, just one atom of sodium here, which is 1 times. Sodium is 23. The aluminium is just one atom also, so 1 times 27, plus oxygen, 2 atoms, 2 times 16. This is what we have right here. So we're going to multiply out. So 1 times 23 is 23. 1 times 27 is 27. 2 times 16 is 32. So we're going to add up. So 23 plus 27 is 50. 50 plus 32 is 82 gram per mole. This is the molecular mass for sodium dioxyaluminate 3. So at this very point in time, we're going to be drawing the content of today's lesson. If you got all those questions right, it means you understood what we took 100% in our previous lesson on atomic mass and molecular mass. So we're going to be drawing the content of today's lesson. If you found this lesson resourceful, please subscribe to this very channel and share this exposition with others. See you in the next exposition. Thanks.